Today, we will discuss the traditional stamp charging coke oven. Compared with top charging coke ovens, stamp charging represents a comprehensive technological advancement. It improves the coking environment, expands the range of usable coal resources, and can significantly enhance product quality or reduce production costs. Stamp charging technology widens the scope of resource utilization, thus requiring more precise coal blending and the scientific combination of product and process. Otherwise, this more advanced process may instead lead to additional issues. For example, if we apply the same coal blending ratio used in top charging ovens to stamp charging coking, the pore structure of the resulting coke will differ significantly, affecting the stable operation of the blast furnace. Another example, under the same volatility conditions, excessive expansion pressure or difficulty in coke pushing may occur, causing damage to the coke oven. The third example is increasing the proportion of gas coal to raise the volatile matter in the blend, which may adversely affect coke's microstructure. However, these issues are not defects of the stamp charging process itself, but rather technical problems to fully utilize its advantages. The process of resolving this issue is in fact the process of reducing the cost of coal charged into the oven, and also a test of our understanding of coke ovens and coal. The essence of the first two issues lies in the excess of strongly caking coals resulted from improved coking conditions of stamp charging ovens. The solution is to increase the proportion of gas coal and other non-strongly caking coals, thereby producing coke of comparable quality to that from top charging ovens while further reducing cost. The latter issue can be addressed by adjusting ash chemistry and optimizing material composition, and this process does not necessarily increase raw material costs. Today, the research on coking coal and coke is already sufficient to resolve various issues in coke production and application. Any requirement of the steel industry for coke produced with traditional oven, including practical demands during blast furnace operation, can in fact be met by stamp charging coke ovens. Regarding these issues, I have previously held in-depth discussions with many experts at home and abroad. There is a general consensus that the claim that stamp charging coke is unsuitable for certain large blast furnaces and the resulting phenomenon of higher prices for top charging coke are largely due to the steel industry in China having an insufficient understanding of coking coal and the stamp charging technology, or the inability of the steel industry to clearly define specific coke quality requirements under blast furnace operating conditions. Alright, if you have any questions, feel free to message me. See you next time.